Hi everyone, I'm Pramod Misra. I'm co-founder of 5G Vector and machine learning consultant. Before this, I had my last role was as lead data scientist with Vodafone. I have also worked with companies like Novartis, Procter and Gamble, primarily in the data science and machine learning domain, almost more than 20 years in this domain. Today I will be covering this topic of knowledge graphs. So one disclaimer: it's in itself it's a huge topic. It's a there are many books or universities do sometimes a 3 credit course on this, but I will try to cover what are the some of the pointers in each of these areas, and feel free to ask questions wherever you have any doubts. So what I'll be covering is one is in terms of why we need knowledge graphs at all, what exactly they are, okay? And some of the examples of knowledge graphs or data science in industry and academia, what all the things we need to deploy it. And I will also talk about one or two use cases which recently I have worked on to give you a flavor of how it can help. Okay, now the first thing is why at all anyone, whether it's in industry or in academia, you need some knowledge graphs. It's basically if you have smaller number of tables. I mean, I'm sure all of us has worked at some point in some SQL databases. So as long as you're working on some small or limited number of tables, then SQL work pretty well. Right? So for example, this is one example. You have a company, you have salary list, ERP, CRM, right? It works well. The moment we start adding more and more data tables, the performance of your SQL query start going down, right? And as it starts going down, we tend to spend a lot more time in just running those queries. And also, after a certain stage, probably no one in the team will realize that, how big is this query and is it really covering what we're trying to extract. Okay? So in now, if you see majority of organizations where we are trying to capture social data, your data coming from web, etc. Right? For that, we definitely need graph databases, and that's where the need of knowledge graphs and network science comes in place. In terms of a brief history, or especially the reason of this 2012 period, because in 2012 first, Google published in their blog about that they're using knowledge graphs for their search engine, and similarly then Facebook and most of the big techs started publishing about it. I mean, if you see the pre 99 or pre 2K era, where we most of the search engines were linked with indexing, and then we have this whole decade of page rank algorithm and its optimization. And I think the post 12 is where companies have started claiming also about a lot more work on connected data, right? And the big part of this is you have probably multiple data tables, multiple data sources. You want to connect it efficiently. You want to run these algorithms, run these queries efficiently. Okay? In fact, this has also led to one new designation in the companies also, which we call as the knowledge engineer, which is kind of an interface between a data scientists and the business user, right? And those who are having expertise in the knowledge graphs. Okay. And also, what exactly is a knowledge graph? So, in pure from a data architect perspective, it's simply a virtual, I would say, data layer, right, which sits on top of all your existing databases. Okay, so it basically facilitates how you can connect multiple databases, tables, etc. Whether it's a structured data, unstructured data. So whether it's a comments, post, queries, or whether it's multiple tables which you have in your team. Okay, I'm sure you must have, many of you must have seen the first two parts of this thing, where we talk about how the era of computing has evolved, right from where the procedural era, where we are coding in terms of with certain rules in the raw data, and we get the answers, and also we try to explain those answers with those procedural codes. Okay, whereas then we have post 2K this machine learning era, where we use the basically the machine learning models, right? Where I ingest the raw data and I ingest my requirement, right? And then we get the rules. Okay. The only limitation in this whole machine learning era is that most of the time you do not get the reasons why or explanations why it is happening. Okay. If a algorithm is predicting something, a better credit score or a higher or lower, or probably a recommendation of a particular medicine, why it is doing so. Okay. And that has led to the third era, which is the knowledge graph, right? Where I use machine learning algorithm, but at the same time, I also use these knowledge graphs to ascertain that what probably could be the reason, right? It's not necessarily you always get answer, but yeah, most of the time it tries to give you some connections linked with your recommendations or predictions. Okay. And so where all we can use these knowledge graphs. So it's, if you see the early examples or use cases of knowledge graphs, mostly it is linked to the places where, we have probably a lot of data points or probably a lot of segregated or data tables. So for example, your geo routing, public transport, insurance risk analysis, where we try to link between the coverage and what is the potential risk to the insurer. The one big area again on the content management, and there's a big piece for companies where you have lot many data points or lot many documents in your repository, but if you want to search one contract, it takes a lot of time, really a lot of time to get the right document at the right time. From a telecom perspective, yes, network asset management is a one big area where you use, like, if you have a failure in the network, right? And if you want to quickly find out that because of which tower or which cell the issue is coming, there we use these knowledge graphs. Yeah. The one big piece, web browsing, where Google started using it for knowledge graphs, similarly many other companies. Then gene sequencing, your portfolio analysis is some of the leading, I would say, investment banks are using it in terms of analyzing their portfolio and what is the, I would say, potential risk on their portfolio. On the social media, a lot have been done in terms of, how I can find these, people are connected to each other and how it impacts any decision. In one of the use cases, I will talk about one of these examples and how we have used in to one of our customers. Now, to implement any knowledge graph, what are the basic elements we need? So one element is basically the one of the graph databases, right? So we need to have, I would say, a data storage and processing. So basically, your graph compute engine or graph databases. Then again, you also need a coding framework. So it could be, any of the graph algorithm, your APIs, certain APIs, and I will talk about that, some of them. And at the last, how we want to visualize it. So in which are the other libraries? So there are both open source as well as proprietary libraries for implementing this. Okay. In terms of what are the main varieties of knowledge graphs, so in that I find what Gartner's have created as Gartner's 5 graph pretty interesting, and in a way it covers all the 5 major use cases. So right from interest, like how people get interested, how it is linked to people profile, then payment is a very interesting, and also it is being used now in fraud and many other use cases, right? That how the money, even in the money laundering cases, some of the companies are using it. Social graph, we all know about it, right? From Facebook to many of the tech have used it intensely. The another big one is the intent graph, right? Understanding the when someone buys a particular product, right? Why someone is clicking on it? What is the intention of that, right? And the last and not least is the mobile graph. So these are the, I would say, the 5 big graphs which Gartner's predicted. Nevertheless, in terms of, if you see the deployment of these graph databases, one of the key element is your this graph database cluster, which basically we one of, you can take Neo4j or any existing graph database which you want to use. And then we connect this graph database to your all existing databases. Okay. You can do actually any of the things, whether it's ETL is, those who do not know ETL, so basically extract, transform, load, where we want to basically transform our data in a certain format, which helps us to report. The best part of or the biggest leverage you get from these graph databases is on the visualization, because sometimes many of the we do not get enough information from the table which is there, and probably even when we see the values, whereas when we represent it in a network or in a linkages, it's much more easier to connect with that story. So that's where knowledge graphs helps in terms of I would say explanation or the root causes of many issues. So this is one of the use cases where I've seen this working pretty effectively. This is Glassdoor using or in Glassdoor's integration with the Facebook data. Okay. And when Glassdoor started it, they were having a difficulty in terms of getting enough, I would say, job recommendation, because mostly these job recommendations go through your friends network. Okay. And when they connected this, the Glassdoor data along with the Facebook, right, that's where they use this, in this particular case, they use the Neo4j cluster as a graph database. And they're find pretty interesting. One is insights. Second is also, I would say, the right recommendations for the, for the job seekers. So that was I would say, a very interesting and powerful use case. Having said that, it's not limited only to these kind of problems. It could be used anywhere, right from finding the right job to finding the right web page, or to the finding the right product. This is another where actually 5G Vector had worked with one of the leading insurance companies. So those of you who have worked on natural language processing, one of the even now one of the biggest difficulty in NLP is understanding these I would say semantic rules or getting the intent of the text. Okay, so because in NLP the challenge comes as that, because we break any sentence into small groups and we try to find the intent of it, and that's where the algorithms start giving a lower performance. Now, what's the help we get from a knowledge graph or any I would say similar solution is I try to put the linkages between different pieces of words. Okay, so that's where in the deep text analysis it becomes extremely useful. For example, in this case, the insurance company wanted to connect the reviews, what people have written about their product on Google or other social media, and linking it with what kind of a products are most purchased on their website. Okay. And to do at scale, you need something which can quickly query this data, and you can throw results on it. So that's where the knowledge graph is extremely useful, because it adds the context of different keywords within the same sentence. So that's how it helps in this whole I would say semantics. This was one use case where we have worked on one of the leading telecom company. The use case was this company have like maybe around some 12 different sales territories, and in each sales territory they have a leading I would say sales manager or a sales lead, and then they have a team of probably 10 to 12 in below the each sales lead. Okay. Now the use case they are trying to solve is that, is there a link between the performance of these sales leads with the what kind of a communication they are doing within the team and across the teams. Okay. And so for that we worked with this company, and what we did was we got only the one of the interesting data set here was the email interaction of the sales lead. So we have not taken the text or the content of the email, and because that was not of interest for a company and neither for us. What we are interested as that person A, to whom I'm most frequently interacting on email and to whom I'm interacting least. Okay, and if and the hypothesis was that if someone is more interactive or at the center of the graph, is he or she will be doing better as a sales lead versus someone who's isolated. And these different charts you see on the right side, right? So here you'll see someone at the center, right? So this is one sales lead we find that who's very frequently, and these small numbers is that how many times in a month they have interacted with each other. Okay? And we also find some many islands, right? So we found some sales people who are not interacting, or they are only interacting with a smaller group. Okay, so these insights, when we presented and when we linked with the performance of the sales, we got very interesting insights. There are some who are like for them the betweenness centrality is pretty high, so they seem to be a big influencer in the whole team, not only within their team but across all the 12 regions. There are some who are kind of on the island, so they are like hardly interacting with the rest of the team, and so they were the one who are finding or complaining about difficulty in getting support from the central office. So these were some of the interesting insights we got by doing this analysis of the use case. So yeah, that's all I wanted to cover. As I said, it's a huge area, and the use cases are unlimited, but yeah, it depends on how we want to implement and how we can leverage in our existing team. Thank you. Any questions?
Do we have any questions for Pramod? Any comments or anything like that?
I have a question, Pramod. Have you done this in an academic context? You said industry and academic.
Yes, so I have done with one of the, I would say, university, but the use case was that they wanted to find out across different courses or different, I would say, the major themes which they're, offering to the students, and linking it with the what students are talking about them, those courses on Google or social media. So that was the one use case where we worked that. So whether people are talking more about a particular, I would say, computer science or a data science course, or about a humanities course, and how it is linked with the, how much enrollment they get in these courses.
So this is Mark. Are you using any specific query language to query graphs, or what kind of language are you using?
Yes, so in our case, we are all in team of Python developers, so we primarily use Python. But if you go across the different solutions, so for example, Neo4j, their graph database works with both Python as well as Cypher. Cypher gives you a bit in terms of language construct. It is, I would say, partly similar to SQL. So that's another. But in general, if you want to use any open source, I think Python coding gives you all the available tools for running any knowledge graph or any graph database for that. Did that answer your question?
Yeah, yes, because I think the graph representation depends on the type of problem, because the graphs can model anything. It can be a structure, it can be some statistics, can be so it is language. So when you are building this graph and then you try to query, yes, so the query is based on the semantic of the graph, yeah. So So I try to understand if there is what language is, if language is specific to a specific type of graph or is general purpose. Because Python, you need to specify what you are looking for. Yes. So if you represent the structure, yes, the connection of routes, for example, or social media, the semantic is different. So yes. I try to understand how, if you have specific libraries for specific type of graph, or you have general libraries, and then you can instantiate these libraries to query the specific type of graphs.
Yeah, so one of the most used library we found was NetworkX, that gives us for most of the general purpose graphs. So NetworkX is one. Then we, in most of the common purpose use cases, you can use it within Python. Apart from that, in some places where our customers are already using, for example, there you're using Neo4j. So in that case, we end up writing queries in Cypher as well. Okay, but because that querying is pretty similar to what we do in Python, so there were small changes. But otherwise, for a general purpose graphs, I found NetworkX is the most useful one.
Okay, thank you.
Okay. Any other questions or comments for Pramod? Okay, great. So
I have one more if we're gonna
yeah.
do it, but
yeah.
So in the context of this working group, we talk a lot about people who are starting programs, and you mentioned using this as a knowledge graph. We actually have someone coming in August that's talking about how they're using natural language processing to look at their course connections. And so it seems like something that could be done at a university level to look at what courses are being taught and how connected they are and how related they might be to a specific topic area like data science or big data or artificial intelligence. So have you seen that done anywhere? Or is this something that is generally not used, or you just have you seen interesting use cases of kind of internally evaluation for universities with knowledge graphs?
Yes, so yes, you're right. So I have, I mean, I had a discussion with one of the university where they suggested something similar, but at this is just because see, one of the prerequisite for knowledge graphs is that they need to have this whole data at least structured in different databases. Okay, if they're capturing it, then it becomes easier to implement. So that's the in this case where I had this discussion. So in one university they were not having that data readily available, so they took some time and they said probably they will start 3 months later when they start capturing this data for at least a 3 to 6 months period. But yes, it's a very interesting use case, and that's the power of knowledge graphs, that as long as you have one connector, or I would say one unique identifier which you can connect to multiple data points, it gives you very, very interesting insights. So yeah, that can be definitely explored, and especially in NLP where I would say both from a university as well as industry, they're trying now to implement at the production scale. Knowledge graphs becomes very useful.
Okay, great. I saw that Carl had his hand up and then Noel.
Yeah, so the interesting question that you asked about the knowledge graph, I have seen, and I'm blanking now, but I know there's at least one like math placement assessment program out there that actually does this around fundamental knowledge graphs and what students need to know in order to progress through topics. So it's able to use the knowledge graph to pick out what questions to present to students to actually place them into more advanced math locations. And I don't remember if it's out of Wiley or somewhere else. There've been a bunch of presentations at some of the JMMs and stuff like that. But I also, it certainly would be very applicable to be able to pull out those graphs of course topics. And I don't recall, I've seen someone talking about doing that sort of idea, but I don't remember where it is. So it's out there somewhere if someone wants to go dig it up.
Yeah, you're right. You're right. Right now, I had some active discussion with some of the universities, and it's exactly on the same lines, because this enables you to many times connect many different parts of the story, which typically a business user or someone who's domain expert who would like to know it, but because of limitation of databases or limitation of data points, they were not able to connect so far. So yeah, definitely.
Wonderful. No, go ahead.
Yeah, I would add off of your remarks and also Carl. We actually at University of North Carolina, Greensboro have used mapping software to analyze course descriptions of close to 3,600 courses, and out of in data science, and have mapped all of that. And we're currently using the same program with another university who has purchased our services to map out their entire curriculum. And we've added both undergraduate and graduate courses. So we'd be happy to present the results of that. It's intriguing because we discovered that data science, broadly speaking, including methodologies within that broad topic, are replete across the university. And one of the findings, obviously, is that faculty are not speaking with one another. And we've also conducted this in terms of specific topics that are being taught in various departments, divisions, whether it's music, sociology, data analysis, whatever it may be. So it's incredibly insightful. And Carl, I'm wondering whether that's the
So it was
kind of
actually a different work. So it was your colleague that presented with me on with me and Carl and Uma on a panel for a data science education series. So actually he's coming back in August to actually speak to this group and to present out on that work. So that's what I was thinking about. So we got a preview on a panel of the outputs. Yes, Carl says tears when he talks. So that did happen last month, and he did an excellent presentation. So we wanted him to come and actually speak to the full group. So in August, he'll be one of the speakers.
Okay, who is that again? I'm sorry.
So it is
Samia.
Somya?
yeah.
Mhm.
Yeah, Somya Mohanty, exactly right.
Mhm.
Okay, well, terrific. I wasn't aware of that. My
Yeah,
apologies.
so he'll be here in August, and that's what made me ask the question too, because I was thinking about the knowledge graph piece. So for anyone that wants to see it done in a university context, come back in August.